under a SAT math problem, there is a figure given over here. Two rectangles are shown in the figure above. If AB equals to 4, AD equals to 2, and BC equals to 8, what is the area of the shaded region? So we have to find the area of the shaded region. Okay, now let me draw a horizontal line over here. So this horizontal line splits the shaded region into two parts. One is a rectangle over here, and the other one is a right triangle over here, because we have a right angle here. Okay, now let's consider the length of AD, that is 2. Then what is the length of this part? This is also 2. Because this is a rectangle, then opposite sides are parallel and equal in length. And since this length is 2 and this length is 8, that is the length of this rectangle over here is 8 and the width of the rectangle over here is 2. And now we can multiply the length and width to get the area of the rectangle we have in the shaded region, that is 16 square units. This is the area of the rectangle in the shaded region. And also, what is the length of this line segment? That is 8. Because here we have a rectangle, then opposite sides are parallel and equal in length. Since the length of this side is 8, then the opposite side is also having the same length, 8. Okay, now for this right triangle, we need the area. Once I get the area of this right triangle, I can add the area of this right triangle and the area of this rectangle. Already we got it 16. To get the area of the shaded region. Okay, now to get the area of this right triangle, I need the height of the triangle over here. Already we know the length of the base, that is 8. When I know the height of this triangle, I can multiply this base and height divided by 2 to get the area of this right triangle. How do I have to get the height of this right triangle over here? For that, let me consider the parallel line we have over here. And here we have another line, parallel line. So both of them are parallel lines. Since both of them are parallel lines, this is called transversal. Since the two parallel lines are intersected by a transversal, the angle measured over here, the angle measured over here are corresponding angles and they must be equal in measure. And also here we have a right angle because this is a rectangle. So in a rectangle, each vertex is a right angle. Okay, now let me mark some other new points over here, A, B, C, D, E, and here we have F, and we can mark G over here. Now let's consider the triangle ABG and the triangle GEF. Okay, in the first triangle ABG, I consider the vertex A. Okay, what is the corresponding vertex in this triangle? So the corresponding vertex in the second triangle is G, because the angle measured at the vertex A and the angle measured at the vertex G are equal because they are corresponding angles, since these two parallel lines intersected by the transversal over here. Now let me consider the vertex B in this triangle because we have a right angle over here. And what is the corresponding vertex in this triangle? That is E, because here we have right angle. Let me write it. And the third vertex in this triangle is G, and the third vertex in this triangle is F. And these two triangles are similar by angle similarity postulate, because the angle measure over here at the vertex A, angle measure we have over here at the vertex G in these two triangles are equal. And also the angle measure we have at the vertex B over here, the angle measure we have at the vertex E over here are equal, they are right angles. So the two angle measures of this triangle are equal to the two angle measures of this triangle. By angle similarity postulate, the two triangles, the triangle ABG and triangle GEF, are similar. If two triangles are similar, then the corresponding sides must be proportional. Okay, now let me consider the side AB in the first triangle. What is the corresponding side in the second triangle? For that, we have to consider the letters at the same position. Here, to get the side AB, I consider the first letter and second letter. Now for the corresponding side, we have to consider the letters at the same position. Then we get GE. GE is the corresponding side for the side AB in the first triangle. Now let me take the side BG in the first triangle. What is the corresponding side in the second triangle? That is the EF. So these two ratios must be equal because the two triangles are similar and the corresponding sides are proportional. That means the ratios must be, the ratios of the corresponding sides must be equal. Now we can plug in the value for AB. We know that AB equals to 4. And what is the length of G? The length of G is 8. We can plug in 8 for G. And what is the length of BG? That is 2. And what is the length of EF? That is not known. We can write X. So I assume X as the length of EF. Okay, now we can solve for X in this equation. Okay, 4 goes into 4 one times and 4 goes into 8 two times. Then we get 1 over 2 equals to 2 over X. Now we can do cross multiplication. That is, this 1 has to be multiplied by this x, and I am getting 1 times x is x, and this 2 has to be multiplied by this 2, then I'm getting 4. Okay, now I got the value of x, that is 4. X represents the length of EF, that is 4 units we have over here. Okay, for this right triangle GFE, I know the base and height as well. So the base is 8 and the height is 4. Okay, now let's get the area of the triangle GEF. Let me write the stuff over here. So area of triangle GEF is equal to 1/2 times base times height. Okay, so 1/2 times the base of the triangle is 8 and the height of the triangle is 4. 2 goes into 2 1 times and 2 goes into 8 4 times. So we get 16. So 16 is the area of this right triangle GEF. Already we got the area of this rectangle over here in the shaded region, that is also 16. So to get the total area of this shaded region, we have to add the area of this rectangle and area of this right triangle. That is 16 positive 16, which is equal to 32. The area of the shaded region is 32. We find 32 in answer choice A. The correct answer choice for this question is A.